Hello everyone, welcome to this class. In this class, we are going to do with the second method for solving quadratic equation, which is completing the square. Now, let's solve the first example. 2x squared minus x minus 8 equal to 0. Now, if you look at this equation, remember what I said, not all equations that can be factorized. This equation, obviously, you can't factorize it. By the time you say 2 times 8, you have 16. Remember what we say, AC and is equal to 16 and B is equal to minus 1. There is no two numbers you can choose where when you multiply 1 you get 16, and when you do the normal rules I said this is minus. Minus means the bigger one will have minus and the smaller one will have plus. When you do the two addition you get minus 1. There is no two rational number that can give you that. The factors of 16 are just 2, 4 and 8. So there is no way you can add any of this and get negative 1, unless you want to deal with irrational numbers. So when you come to case like this, factorization can no longer work. You have to look for another method. Either you're using the completing the square method or using the quadratic formula. Graph also works. Now, completing the square method, when we talk about completing the square, what do we mean? Completing the square. What do we mean? It means that we are trying to convert an equation to a square or a perfect square. Let me put it that way. Let me give you an example. You have something like x squared plus plus x. This is a quadratic equation because x is already square. We are trying to say, okay, what can I add to this equation to make it a perfect, a squared, like a square of a number, like a perfect square. Now the formula I will give you is a note. Make sure that the coefficient of this x square, which is a, remember our general formula where we have ax squared plus bx plus c. The coefficient of our x square, make sure that a is equal to 1 before you solve. So in this case, a is 1 already, so we can solve. Our b is 1 in this case. So what you're going to add is just add, let me put it here, add b over 2 all squared to the equation. Once you add it, you make the equation a perfect square. So let's solve. We have x squared plus x. Our b is already 1, so b over 2 all squared in this case will be 1 over 2 all squared. So plus 1 over 2 all squared. This is equal to x squared plus x plus 1 over 4. If you solve this equation using our factorization method, because of time, let's just jump. But if you solve this using our factorization method, check the previous video and you see our factorization method there. This video, once you check the previous video, you see our factorization method. If you solve it, you're going to get something like x plus 1 over 2 all square. This will be your answer. Just for the benefit of this class, I'll solve it, but going forward, I will not solve any other example. So remember what I said in the previous video. Our a here is 1, our b is 1, 2, this is b, while our c is 1 over 4. So using factorization method, you look for a times c is 1 times 1 over 4, which is 1 over 4. So you look for two numbers that when you multiply them, you get this. When you add them, you get b. Now this is plus plus. If you are to use by the rule I give, the two numbers will be two positive numbers. So in this case, it's 1 over 2 and 1 over 2. When you multiply 1 over 2 by 1 over 2, you get 1 over 4. When you add both of them, you get 1. So let's solve. We now have x squared plus x over 2 plus x over 2 plus 1 over 4. We are factorizing this equation now. You have x squared. Sorry, you choose like term. So in this case, I'll choose x. X divided by x squared. X squared divided by x, you have x plus x over 2 divided by x, you have 1 over 2 plus, in this case, I'll choose 1 over 2. X over 2 divided by 1 over 2, you still have x 1 over 4 divided by 1 over 2, we still have 1 over 2. So now this in the bracket are the same. So we have 1 x plus 1 over 2 bracket x plus 1 over 2. This is the same thing as x plus 1 over 2 all squared. That's the solving of this. So at the end of the day, you've ended up making this equation here a perfect square. Let's solve another example before I proceed. Let's say I have something like x 2x squared plus 4x. So what am I going to do first? Remember what I said before you do the completing of the square method, this a here must be 1. So I'll first divide both of the two equation by 2. I will have x squared plus 2x. So this is what I'm going to do the completing of the square method. So b in this case here now is 2. And remember, you are going to add b over 2 all squared. So b over 2 all squared in this case is 1 square, because 2 over 2 is 1 all square, which is still 1. So I will solve for the equation. I have x squared plus 2x plus 1. Now I'm not going to solve this factorization method. Just go to the previous video, you'll see it. I'll also put the link in the description for those that are not here when we do the factorization method. So what are you going to do? If you solve for this, you are going to get x plus 1 all squared. So we've been able to convert this to a perfect square. So let's solve this equation. By the time we solve this equation, you understand why we have to do this. 2x squared minus x minus 8. Now remember equal to 0. Remember what I said in the previous example. There is no how we can make this through factorization. That's why we're using completing the square. So the first step we are going to take is first, or let me solve this in the next page so that we'll see the question all through. 2x squared minus x minus 8 is equal to 0. So because we are solving completing the square method, we are going to make sure that the equation of the value of a is 1. So we divide all this by 2. So we have x squared minus x over 2 minus, okay, 8 over 2 is 4 equal to 0. Now when we solve completing of the square method, this is what we targeted: x, a and b. That's x and then x squared and x. So in that case, we're going to take this 4 across the equation. So we have x squared minus x over 2. When 4 minus 4 across the equation, it becomes plus 4 equal to 4. Now let's complete this equation. Now in this case, what is b here? B is minus 1 over 2. So b square will be, sorry, b over 2 all squared. B over 2 all squared will be minus 1 over 4 all squared, which will give you 1 over 16. So we are going to add 1 over 16 to this equation. We will have x squared minus x over 2 plus 1 over 16. We have negative here and positive here, because when minus multiply itself is positive, equal to 4. Now, mind you, this was equal to 4. Now we've added something here. We still need to add that same thing here. If we didn't add it, if we not add whatever we add here to here, this equation is no longer correct, because you can't say 2 is equal to 2. All of a sudden you add 1 here, and you now want to tell me that 3 is equal to 2. No, you also have to add that 1 here too, so that it will still remain equal. So in that case, we are still adding this 1 over 16 at this side of the equation. So when you are solving for completing the square method, whatever you add, when you add that extra value to complete the square, you also need to add it at the other side of the equation. Take note of that. So if we solve for this, we are going to, using factorization method, we'll be jumping step, please. We'll be jumping steps because of time. We'll have something like x minus 1 over 2, x minus 1 over 4, all squared. This is what we are going to, this is what this thing will give us. If you open up this, you find that you are still getting this back. So this will be equal to, I'll add this side, 16, 4 divided by 16. This is like 4 and 1 over 16. 4 plus 1 over 16. So I'll add this side using the normal addition of fraction method. This is like 4 over 1, right? 1 divided by 16 divided by 1 is 16. 16 times 4, 64, plus 1. In this case, you are having 65 over 16. Now, we have this is equal to this. We have that this is equal to this. Now you can apply your simple basic mathematics. Because here is in square, you find square root of both sides to remove this square. When you find square root of both sides, it will become x minus 1 over 4 is equal to square root of 65 over 16. Now, make sure you don't forget to add plus or minus. You are solving quadratic equation, so everything counts. Why are we adding this plus or minus? Let me show you. If you have minus 4 and you have been told to find the square of minus 4, it is minus 4 times minus 4, which will give you what? Minus 4 square is will give you 16. The same way, if you have 4 and you have been told to find the square of 4, it is still 4 times 4, which will still give you 16. So when you find the square root of a number, you don't know which of them give you that number. It's either the negative of that number give you the number or the positive. That's what we are taking into. So this plus minus means it's either plus root 65 over 16 that gave us this, or minus 65 over 16 that gave us this. So we are considering every possible scenario. So in that case, x will now be, when this comes cross equation, it becomes 1 over 4 plus or minus root 65 over 16. Now you are going to get two answers. What do you mean? What do I mean? X1, that's first x. Let me not put x is either 1 over 4 plus root. Hey, sorry for this mistake. Those that notice it, you are a genius. X is either 1 over 4, 65 over 16, or x is 1 over 4 minus root 65 over, why am I always putting 16? 65 over 16. These are the two answers. So whatever you get here, you will notice that this is already an irrational root. When you solve for this root, you're getting an irrational answer. That's why you can notice that completing the square method cannot solve. Not all it can solve. So when you solve for this, you just use your calculator. Just punch your calculator and solve for this. You will get, this will give you 2.27, while this will give you 1.77. So you will say x is equal to this or that. This is your answer. This is how to solve for completing the square method. You know how to prove that this thing is working. I'll look for one of the example we did in our previous class and we'll try to solve it using the completing the square method. We solved for, let me take this example. We solved in our previous class, y squared plus 8y plus 16. Y squared plus 8y plus 16 equal to 0. Now, because you are solving for completing the square method, we'll take this 16 out of this place. You have y squared plus 8y. Now, mind you, the quotient of the square, that's a, is already 1. That's why we are solving immediately. Is equal to minus 16. When you do what? when you take this out. Now let's complete the square for this. B is what? 8. Now for us to complete the square, we add b over 2 all squared, which will be 8 over 2 all squared. 8 over 2 is what? 4. 4 square is what? 16. Are we following up? So we now have y squared plus 8y plus 16 equal to minus 16. Whatever we add here, we add it the other side, plus 16. Now you have y squared plus 8y plus 16 equal to, this thing will give us 0. So as you can see, no need for me to even continue solving, because at the end of the day, we've already gotten the initial question. So we just factorize and we get our answer, which will be equal to what we did in the previous class, and we still get the answer. This is the steps we followed. So this is to tell you that completing the square method is working, but most of the time it's good to use it where factorization fails, or maybe you're writing an exam, you are being told specifically to use it. Let's go to an exercise and solve at least one question. This is exercise 3A, number 4A. This is the question they were given. So first thing first, we are going to rearrange this equation to give us the pattern we use to solve, the pattern of ax squared plus bx plus c equal to 0. That's the first thing we are going to do. So when you open this, let me bring this to the other side of the equation. I have x squared minus 2 1 minus x equal to 0. Now open up the bracket. I will have, open up the bracket, I'll have x squared minus 2 times 1 minus 2 times 1, which is 2, minus 2 times minus x, which is plus 2x. Always be careful for this negative sign. It causes a lot of problem. Equal to 0. Now rearrange it to x squared plus 2x minus 2 equal to 0. Now we already know our a, our b, and our c. Solving using the completing the square method. Mind you, in this example, we are being told to give our answer in solved form. So we already know what solved is, irrational roots. So at the end of the day, I will now take this to the other side of the equation. I'll have x squared plus 2x equal to 2. When negative 2 cross equation becomes positive 2. Now what are we going to add here to complete it? Our b is 2. So what we are supposed to add is b over 2 all squared. So b over 2 is the same as 2 over 2, which is the same as 1. So square root of 1 is still 1. So we're adding 1 here. So I'll have s squared plus 2x plus 1 equal to, anything you do here, you do it here too. 2 plus 1. So when you solve this equation using the factorization method, as I said earlier, I'll be jumping steps because we've done this and it's the simplest way. So what my answer will give me is x plus 1 all squared, which is equal to 3. Which is equal to 3. Now I'll start solving. Square both sides. I'll have x plus 1 is equal to plus or minus root 3. When you are solving for completing square method, always don't just square it as we do in other maths. Make sure you put the plus or minus sign, because we're trying to consider all the possible values of x that will give us this answer. So the next is make x the subject of the formula. It will become minus 1 plus or minus root 3. So this is our answer. So x will now be minus 1 plus root 3 or minus 1 minus root 3. So these are the two answers for x. Let's solve another example so that we'll use it to refresh our memory on this. This is exercise 3A, number 4B. This is the question. So the first thing we are going to do is put this in this form. So first, let's open up the bracket. We have y times y. We have y squared minus y times 3. 3y is equal to y minus 1. So we'll bring this to the other side of the equation. Y squared minus 3y. Y is plus here, so it will be negative when you close the equation. 1 is plus here, so it will be positive. But let's not move 1 since we don't need it. So let's leave it where it is, equal to minus 1. Since when you are completing the square method, all we need is the y square and the y. But if I bring it here, at the end I'll still take it back again, so no need to repeat that. So I'll have y squared minus 3y minus y is minus 4y equal to minus 1. In this case, our coefficient here is 1. For that reason, no need to divide. I'll try to solve another one where the coefficient is more than 1, so we can divide and still solve. So b is minus 4. So b over 2 all squared is minus 4 over 2 all squared, which is the same thing as minus 2 all squared, which is the same thing as 4. So when I'll add 4 here, y squared minus 4y plus 4. Just know that, let me give you a little hint. Just know whatever you're adding here will be positive, because the square of the number will always make it positive. Because some of us might be confused about that. Just know that what you add here must always, whatever you're adding to this equation to complete it as a square will always be positive, because you're multiplying it by itself. And whenever you multiply negative, if it's negative, the multiplication, the squaring of it will still turn it to positive back. So take note of that, which is equal to minus 1. Because we added 4 here, we're also adding 4 here too, plus 4. So when we solve this using the factorization method, this is equal to 3. So when we solve this using the factorization method, we have y minus 2 all squared is equal to 3. So we find the square root of both sides. We have y minus 2 equal to 3 plus or minus root 3. So y, making y the solution formula, is 2 plus or minus root 3. Therefore, y is now 2 plus root 3 or 2 minus root 3. This is the answer. So you can see that we are getting, if you use your calculator and punch this, you get here, you have like 2 point something, or root 3. I think root 3 is more than 1, so it will be like 3 point something. While here you have like maybe 1 point something or 0 point something. So you can see that we are using completing square method to solve an answer that will give us an irrational root, which factorization cannot do. And when you take this irrational root and put it back in the equation, you get something that is very close. Like it will be close, because irrational root, it can't give you a definite, but it will be very close to the answer. So let's solve another one. So this is the next question. Now it's already in the form we want it to be. No, we are not touching it. But the only thing is that a here is 2, so we have to make a to be 1. So it will be x squared minus 3 over 2x equal to 3. By the time you divide all of them by 2, this is what you get next. Now our b is minus 3 over 2. B is anyone that is behind x, the coefficient of x. So b over 2 all squared is the same as minus 3 over 4 all squared, which is the same as 9 over 16. That's what we are adding here. So we have x squared minus 3 over 2x plus 9 over 16 equal to 3 plus 9 over 16. When you solve for this using factorization method, you have something like x minus 3 over 4 or squared. Let me give you a little hint that you use to solve for this. Whenever you do the completing of the square method, that you have added the answer, just know that your answer will be, this x squared will just be only x. Whatever sign you have here, you use the normal rule I taught you in the last class, that if it's 9, but I think the best way to go about it is whatever sign you have here is what you will have here too. If you have plus here, you have plus here. If you have minus here, you have minus here. I'll show you the other ones we've done to prove it. Then the second option you have here is what you have inside here. You see what you have inside here when you are trying to solve for b minus 2 squared. That's what will be here. Or you can just say x and b over 2. That's what you have inside here. If you solve it using factorization method, you still get this answer. But this I'm talking about shortcut. Let me show it in the other example. Look at this example. After I've gotten this, if you notice, I have y minus, you see it, my b is minus 4, so minus 4 over 2, that's what we have here, minus 2 all squared. Let's check the other example. Where did I start? After I've gotten this my equation, you see there's plus here, there's still plus here, so my b is 2, b over 2 is 1. So instead of going through the rigorous process of factorizing and solving, you can just jump the step. Where is the other example we did? This is it. This one is x squared minus, this is the equation. When we want to convert, when we want to factorize it, x will come down. This b is minus 1 over 2. So minus 1 over 2 divided by 2 is minus 1 over 4, all squared. Then you solve for the other side of the equation. So this is the shortcut you can use while solving completing the square method. Note, while solving completing the square method, don't use it in other places. It works very 100% here. So this is equal to 3 plus 9 over 16. So if I'm to solve for 3 plus 9 over 10, this will now be 3 over 1, 16. 16 divided by 1, 16 divided by 1 is still 16 times 3, 48. When you want to solve for completing the square method, you have ax squared minus bx plus c equal to 0. Now, you just have to do what? Take c to the other side of the equation. You have ax squared, sorry, this plus, let's use plus throughout, plus bx equal to minus c. So you add the coefficient, that you add the b, you add b over 2 all squared to both sides of the equation. You have a, mind you, I made a mistake because this is a, so I'm supposed to divide it. Get, so before I even start solving this add side, I'm supposed to have divide through by a. I'm supposed to have something like s squared plus b over a x equal to minus c over a. So you now add this coefficient here, divide it by 2 and multiply by itself and add it to both sides. I have something like s squared plus b over 2a, sorry, I'm getting something wrong, b over ax plus, now this is my b, my new b. Now if I'm to solve it, it will be b over a, but because I want to divide it by 2 first, so it will be 2a, then the square. Are you following? So the square will now be b square over 4a square. That's what we are going to add to here and to here. So if I add it, it will become b square over, make circle this out so it doesn't look like it's joining our equation, over 4a square equal to minus c over a plus b square over 4a squared. Are we following? So I'm just using characters, let me say variables, to solve so that you get what we are doing when we are solving it with numbers. Now, if you factorize this, remember the hint I gave you. Just put your x here plus this coefficient here divided by 2. So it will be b over 2a all squared. If you solve it with the normals we will use to solve factorization, you still end up here. I just have to stop factorizing to reduce the time of the lecture and to save our time. So this will be equal to, you add whatever you have here. So you have 4a as your 4a squared as your denominator, common factor between these two. So 4a divided by a, 4a squared divided by a, you have 4a. 4a times c, you have minus 4ac plus this divided by this 1, so it will give you b squared. You can also rewrite this as b squared minus 4ac all over 4a squared. Are we following? So we'll find the square root of both sides, the square root of this and this. So I'll have something like x plus b over 2a equal to plus or minus square root of b square minus 4ac all over 4a squared. Are we following? So we find the square root of this down. This is a perfect square, so we can find the square root. So we have something like x plus b over 2a equal to plus or minus b square minus 4ac all over 2a, because square root of 4 is 2, square root of a square is a. Are we following? Now make x the subject of the formula. X will now become minus b over 2a plus or minus b square minus 4ac all divided by 2a. So if we solve it with our normal fraction, this will be equal to, the both of them has 2a, so it will be 2a, 2 divided by 2a is 1, 1 times 2, have minus b. Are we following? Plus or minus, this divide the same, and 2a divided by 2a, 1 times what we have in the numerator, we have b square minus 4ac. So x is now equal to minus b plus or minus b square minus 4ac all divided by 2a. So this is what we call the quadratic formula, which some people call it the almighty formula, and that's what we are going to do in our next class. So it's very important to know that this quadratic formula was derived from completing the square method. Instead of you to be going through this whole rigorous process of solving for this, it has been derived in like a formula where you don't need to go and start you just find your b, plug it here, find your a, plug it here, find your c, plug it. At the end of the day, you solve for this. Mind you, this equation also means x is equal to, this equation also means x is equal to, let me say something like minus b plus or minus, okay, minus b plus b square minus 4ac over 2. X is this, or x is minus b minus, so you have to squeeze everything here, b square minus 4ac all over 2. So these are the two roots of x. But the point I'm making out here is that this is the almighty, this is the quadratic formula derived from completing the square method. If you have any question, you can drop it in the comment section. Thank you and see you in the next class.